Okay, this is a continuation of Review 6, R.6, though this is R.6b as in boy. Page number 41. We just got done with, looks like we were getting done with example 2, so let's push on to example 3. And what we're doing here is making sure that we read that paragraph there in the middle of the page. In many situations, radicands are never formed by raising negative quantities to even powers. In such case, absolute value notation is not required. So we will henceforth assume that no radicands are formed by raising negative quantities to even powers. So all the absolute value things they did earlier, and I just kind of brushed up on a couple of them there at the end of the last video, are pretty much thrown out. So we'll just continue on with same old, same old. So let's go ahead and get started here. So perform the operations indicated. We have 3 square root of 8x squared minus 5 square root of 2x squared. Alright. So not a whole ton of work in order to do this. So what we're going to do is we're going to first of all look at the number here, the 8, under the radical sign, and factor that down. And again, if you remember from last lesson, we're going to find two numbers multiplied together that give us 8, but we can take the square root of one of the numbers if possible. So that gives me that, and didn't really do anything to 5 to 2x squared. Okay, so we can pull that out. Square root of 4 is 2, so we have 3 times 2 now. And we have 2x squared minus 5 square root of 2x squared there. So we have what we're going to do here is take 6 square root of 2x squared minus 5 square root of 2x squared. And because what's under the radical sign here is the same as what's under the radical sign here, we can subtract 6 minus 5 and get 1. So we get the square root of 2x squared. Now, whenever we have an exponent, we can see if we can pull part of that x or all of that x out. So we look at this exponent here and compare it with the index, which is right there. And we divide this 2 here into this 2 and see how many times it goes into it. In this case, it goes into it 1 time, which means we can pull 1x out of there, and we're done. Okay, the book does a little bit different. There are different ways of doing this, but as long as you're following the rule, you're good to go. Okay, so for this one in example 3, this is part B as in boy, we're just going to use the FOIL method. So we're going to do the first terms first. So 4 times the square root of 3 times the square root of 3 is actually the square root of 3 squared. And then we're going to do the outside. So minus 20 square root of 6. And then we're going to do inside, which is the square root of 6. And then we're going to do last, which is going to be negative 5 square root of 2 squared or square root of 4. So you can either write that as 4 here, or write it as 3 squared when I took this times this. So this could either be the square root of 3 squared or just 9, either way. Okay, so let's go ahead and simplify. This here, because my index is 2 and this is 2, I can just make that 3. So I've got 4 times 3 minus 20 square root of 6 plus square root of 6 minus 5 square root of 4 is 2. So I've got 12 minus, and let's combine these since I have a radical sign of square root of 6 for both of those. Okay. And then that takes us 12 minus 10 is 2 minus 19 square root of 6 for your final answer. Okay. The example 4 for surveying using the Pythagorean theorem, I'm not going to do that. That's pretty simple, and you can look at it if you want to practice that. So let's go to page 43, rationalizing denominators or numerators. Okay, so when we have something like the square root of 3 halves, that is the same as the square root of 3 over the square root of 2. And if you remember, you can't have a radical in the denominator, so we need to get rid of that by multiplying the top and bottom by the square root of 2 over the square root of 2. This is equal to 1, so we're not changing the value of this at all by multiplying by the square root of 2 by the square root of 2. We're just getting rid of our radical in the denominator. So that gives us the square root of 6 over 2, and we're done. When we deal with the cubed root, like in the b part of this, cubed root of 7 over the cubed root of 9, it's a little bit different because we are trying to get rid of the cubed root value. So we need to figure out what in the world we're going to multiply the top and bottom in order to get rid of this. So what we're looking for is we're looking to make this here a 3 cubed. Because if that is a 3 cubed, then we could take then the cubed root of 3 cubed. 3 cubed is 27, so we take the cubed root of it, and that's equal to 3. Then our radical is gone. So that's the direction that we're going to go in this. So we're going to multiply the top and bottom by the cubed root of 3 over the cubed root of 3, because that gives us on the bottom the cubed root of 27. So that gives me the cubed root of 21 on top, which we really don't care what the top is, but the cubed root of 27 is 3. So the cubed root of 21 over 3, and we're done. So the key thing here is to find, and it doesn't have to be the cubed root of 3 over the cubed root of 3. I was just trying to find a number in here that I could take the cubed root of. So I know I can take the cubed root of 27 here and get 3. So that's why I multiplied the 9 by the 3 to get that to be a 27. But it doesn't have to be a 27. It can be any number that you want to take the cubed root of. Okay, so that brings me to rationalizing the numerator in example 6. There are going to be very, very rare times where you're going to want to rationalize a numerator and have a denominator with a rational or a radical, but this is just some practice. So if you remember, when you have things like this, if we multiply by the conjugate, we get rid of our middle term, and when we square our x and our y, it takes the radical sign off. So when we multiply that, we do our FOIL method, and we get the square root of x, the quantity squared, when we multiply that and that. Then we do our inside and outside, which makes the O and the I of FOIL disappears because of the negative here and the positive here. And our last one would be just the square root of y squared over 5. We're going to multiply that times each of those. Square root of x plus 5 square root of y. So this just becomes an x. This just becomes a y over 5 square root of x plus 5 square root of y. And you're done. Now you've got the radicals on the bottom, which is not normally what you want to do, but just learning how to rationalize the numerator in higher level math sometimes is necessary in order to solve what they're asking you to solve. But anyway, rational exponents. We are motivated to define rational exponents so that the properties for integer exponents hold for them as well. So, if you remember, a rational exponent looks like that. That's the square root of x. So it's not written like this. That would be what you would think when you hear rational exponent. But we're talking about x to the 1/2 power. So I would suggest rational exponents, top of page 44, that you at least write those down if you're not going to memorize them, just so you know what happens with your rationals, or your radicals. So when we have 7 to the 3/4 power, and the instructions say convert to radical notation, the bottom number is your index, the top number is your exponent. So you're going to get that. Okay? Or you're going to get the 4th root of 7 cubed. Doesn't matter which order you do those in, it just depends on what's going to make it the easiest to solve. 8 to the negative 5/3 is going to give me 1 over 8 to the positive 5/3. Then I'm going to put the radical on it. So 8 to the 5th, or cubed root of 8 to the 5th. Okay, and again, that's under 1, and that's under 1. Alright, so look at the difference here. Look at this as a possible answer. We take 8 times 8 times 8 times 8 times 8, and then take the cubed root of it for this one. Whereas for this one, the cubed root of 8 is 2, so we have 1 over 2 to the 5th power. We can do 1 over 2 to the 5th power in our head and get 1 over 32. So this one you can do in your head if you follow these instructions. This one here you're going to need a calculator because you're taking 8 to the 5th power first. Okay, so let's continue on. C says m to the 1/6 power. Well, all that is the 6th root of m. Then finally the tricky one, negative 32, and that's in parentheses, 2/5. Alright, so what we're doing there is, first of all, let's go ahead and write this in radical form. And that's negative 32. Now, the question is it negative 32 squared, or is it a parenthesis around those? Well, there was a parenthesis up here, and the negative was included in it, so it's got to be included here. So let's go ahead and leave it that way. Okay. So, when you do this one, you end up getting negative 2 squared equals 4. So as I look at this, I'm thinking, well, maybe I should show you how to do this. Well, let's convert this to the 5th root of negative 32 squared. We can take the 5th root of a negative, because this is odd. You can take the odd root of a negative. So the 5th root of negative 32 is negative 2, because negative 2 times negative 2 is going to give you 32, negative 32. Then we have the squared right there, and that's where our 4 came from. Well, let's look down at example 9, A, B, and C there. So A is x to the 5/6 power, and we're going to multiply that by x to the 2/3. Okay, when you're dealing with exponents and you're multiplying, you're going to add the exponents. So we're just going to add those two together. So you find common denominators. In this case, it's 6. And that gives me x to the 9 over 6. And if you want to change that to radical form, first of all, 9 over 6 can reduce to 3/2. And then that gives you the square root of x cubed, right? Okay. And we know that because our index here is 2, we look at how many times does 2 go into 3. Goes into it 1 time with how many left over? 1x left over. Okay? So it gives us that for an answer. Alright, let's look at B. X plus 3, and that is to the 5/2 power. And we're going to multiply it by x plus 3 to the negative 1/2 power. Alright, so that being the case, we're going to add exponents since we're multiplying, so we have x plus 3. We're going to add exponents, which because this is a negative, we're going to actually subtract. And that gives me x plus 3 to the 4 halves, which is x plus 3 squared. I don't know if I did it a little bit different than the book or not, but anyway, that works. And finally, let's do C. We did some of these, I think, last semester. Okay, I work on the inside out, so I'm going to write cubed root of 7 to the 1/2, because I just did this part. Now I'm going to take 7 to the 1/2 to the 1/3 because of this one. That's my next layer out. So using the power rule, I multiply these and I get 7 to the 1/6, or the 6th root of 7. And I am done with it. So that is the B part of Review 6.